So we're now, Anthony Priscilla doing trig with his trig class, summing difference identities. It says use an appropriate identity to find sine 195 degrees. Well, you need to take that 195 degrees and rewrite it using angles that are on the unit circle. It's got to be an angle on the unit circle. You couldn't say 200 degrees plus 25 degrees, 200 degrees minus 5 degrees, because those are on the unit circle. We've already done one where we had cosine 195 degrees, and I chose to write it as 60 degrees plus 135, but that's sure not the only two angles you could use to get 195 degrees. Like right here, one way we could write it as 195 degrees is to say 225 degrees minus what? 30 degrees? So we could rewrite 195 degrees as 225 degrees minus 30 degrees. And I need a little unit circle to look at. I think I'll do this. It's just my scratch paper here. On a unit circle, 225 degrees is down here in the third quadrant. And in the third quadrant, both x and y are negative. And 225 degrees, what's its reference angle over here? 30, 45, or 60 degrees? It's going to have the same ordered pairs as the 45 degrees. Oh, this is the 225 degrees. Okay. So, and I should have just brought a completed unit circle to pull up here and point, but I didn't. So instead of taking the 30 seconds to go to my office and get it, I'm just doing this. That's 30 degrees right here. What's that ordered pair? It would be right square root of 3 over 2 up a half. And so I'm going to use those to evaluate sine 25 degrees minus 30 degrees. What's that pattern? It's sine, cosine, same symbol, cosine, sine, sine, cosine, cosine, sine, same symbol in the middle. So remember, the ordered pairs are in the form cosine, sine. On the unit circle, those ordered pairs, it's alphabetical. Cosine is the first number, sine the second. Well, sine 225 degrees is negative square root of 2 over 2. Cosine 30 degrees would be square root of 3 over 2. And minus cosine 225 degrees, well, it's the same as sine, negative square root of 2 over 2. And sine 30 degrees is a half. So what's this going to be? A square root of 6 over 4. Ooh, are we going to have two minuses here? Minus, that's the black minus, a negative square root of 2 over 4. So that minus a negative, is that going to be a plus? Square root of 2 over 4.
Is the square root of 6 over 4, that's not negative?
The square root of 6, oh, thanks. You're right, there's the negative there, and a positive there. You're right, thanks, okay. If you hadn't pointed that out, once I realized it, I would have to delete this video. Okay, so 4, what would this be? Negative square root of 6 plus square root of 2. Let's see now, how is it written? Oh, is it one of these? if the minus is out in front, that means distribute it through both. So it's not D. D would have a negative square root of 2 and a plus square root of 6. Now, it's not B. That'd have both of them negative. Is it C? C has, instead of writing the negative square root of 6 first, they wrote square root of 2 minus square root of 6 all over 4. Could y'all go backwards with these ideas? Oh, any questions on that? Let's do number 8. That'll be our last one, just to sort of go backwards on these. So 8 and 9, sine, cosine, cosine, sine. So if I were going to write this as just one identity, one trig function, one term, going backwards, what would I need to do, or what would the sign be right here? Would it be a plus or a minus? It's a minus. Remember, with the signs, it's the same symbol in the middle. So 78 degrees minus 33 degrees, what's that going to be? Is that a 45 degrees? See, here, you were going backwards. Sine, cosine, cosine, sine. So that's sine. And then what symbol is in the middle? Plus or minus? Well, it's the same. So sine 45 degrees. Do y'all have that memorized? What would it be? On the unit circle?
Square root of 2 over 2.
Yeah, square root of 2 over 2. On this one, tangent 87 degrees plus I know I said that the 8 would be the last, but I may as well do this one real fast. Tangent 87 degrees plus tangent 93 degrees. If you're going backwards, the top sign, is that the same or was that changed? That's the same, so I'll put a plus. So it's 87 degrees plus 93 degrees. Are you following how I'm doing that? Is that some difference for tangent? But we're sort of going backwards, aren't we? In math classes, you do it one way, then you go backwards. In algebra, you learn to FOIL, then you started factoring. Even back in grade school, you multiplied and then you divided. So let's see, adding 87 degrees and 93 degrees. Is that going to give me a special angle on the unit circle? What's that going to be? 180 degrees. Oh, okay. So 180, that would be right here. Negative 1, 0. So if we go sine over cosine, what are we getting for tangent 180 degrees? Is it 0? Yeah, 0. Okay. So we've done a lot with sum and difference identities today. So hopefully between now and Wednesday, y'all will work on this. Try to work on them, because we're going to use those to derive the double angle identities as we continue this marvelous journey through all these identities. But by the time of your midterm, we'll be through with these identities. So the last half of the semester will sort of slack up a little.